Good morning, Year 10. The lesson today is on current, potential difference, and resistance. Okay, so a bit of a recap here. Back to lesson 1. I want you to draw and label as many electrical components as you can remember. Okay, and then once you've done them, check back in your workbook to see if you got them right. Also below here are 4 YouTube videos that you can go to, bite-sized, to help you do a bit of revision about electricity. A YouTube video for explaining potential difference, one for current explained, and one for resistance. So spend a bit of time, have a look at these videos, make some notes on them, okay, and then hopefully you'll be able to complete the rest of the tasks. So, current, potential difference and resistance then. We need to recognise that current flows from the power source around the whole circuit, as long as the circuit is a complete circuit and therefore unbroken. We have symbols that represent all of our common components, and this is so that we can standardise it so that everybody knows what's happening in a circuit. And it's used in all circuits that we have. The potential difference then, we sometimes refer to as voltage. This is the flow, the current flows in the circuit. There must be a potential difference. The larger the potential difference, the faster the current will flow. So the larger the voltage, the faster the current will flow, because we're giving more electrical energy to the components in the circuit and to the current to allow it to flow. So wires and components are themselves resistors in some respects. They resist that flow of current and they transfer some of the electrical energy into whatever the component's doing. For example, a bulb would be light and some thermal energy. So this is all what we class as resistance. So there's always resistance in a circuit, even if it's just through the wires as the electrical current is being passed. So Ohm's law is the main one that you need to recognise. This is obeyed when the current is flowing through the material and it is proportional to the potential difference. So the equation for Ohm's law is V is equal to IR, where V is our potential difference in volts, I is the current in amps, and R is the resistance in ohms. So this is one of those equations that you are going to need to know and be able to use and rearrange in your exams. So the easiest way to rearrange formula like this is to use the triangle system, where you can put I, R and V into your triangle to show that I is equal to V over R is equal to V over I, and V is equal to I times R. It's really important that you try and remember this equation for those questions in the exam. So in Ohm's law, if I was to plot a graph of the current against the potential difference, we would have a graph like this, where it is directly proportional. So as the potential difference increases, the current also increases. And we would find that it should fall along this straight line through the origin. Okay, so we're going to start you off with a couple of simple questions. Question number 1, calculate the current through a 60 ohm resistor if the potential difference is 12 volts. And calculate the current through a resistor if we have 3,700 ohms of resistance and a potential difference of 6 volts. I'm going to give you the answers to these questions at the end of the PowerPoint. So write down your answers and we'll come back to those in a bit. If you need to pause the video at this point so that you can have time to calculate this, absolutely fine, and you are allowed to use a calculator. So when it comes to resistance then, the wires and components within a circuit can resist the current flow. Whereas resistors themselves, they can be put into the circuit to reduce or control the current even further. Fixed resistors do not vary in resistance, so they will have a fixed ohmatic resistance. A variable resistor can change with conditions. This may be light, this may be temperature, and this may be something that you control, like a dimmer switch in your house that controls the amount of current flowing and therefore the amount of light that you see. With a light dependent resistor, this is one where light falls onto it and then allows it currents to flow. And a thermistor, again, is the same idea, but with temperature. So the higher the temperature, the more the current will flow. So as I said, you need to know about LDRs, light-dependent resistors. This changes with the light level. So as it increases, the resistance drops. So we can use this quite helpfully to turn lights on automatically when it's dark. So most of our street lights and things will work on that basis. Thermistors change with temperature, reduces the resistance with the lower temperatures. So we can have things like central heating in your homes that can use thermistors to help it. So thinking about what we've just talked about, these are the two more questions to add to the ones that you've already done. See if you can describe the sequence of events in an electric oven controlled by a thermostat as it comes up to temperature and then maintains its temperature. So how would that be working? And number 4, as it slowly gets dark at night, the resistance of an LDR changes. This change eventually triggers a light to come on. If the current through the LDR is 0.2 milliamps, when the light turns on and the PD difference across it is 5 volts, what is the resistance then of the LDR? So these are slightly more typical exam questions. We're going to go through the answers to at the end. So if you need to pause the video here so that you can do these questions, please do so. Okay, so thinking about what you've learnt today then, your plenary for this lesson is to write down 5 things that you've learnt in today. So 5 facts that you've learnt from today's lesson. And on the next slide, I'm going to go through the answers to those questions that you've done, and hopefully you'll be able to mark and get them all right. Okay, so question number 1 asked you to look at calculating the current. So that was 12 divided by 60 to get 0.2 amps. Question number 2 was 1.6 milliamps. And question number 3, as the temperature rises, so the resistance changes. The process circuit senses the resistance change. The output circuit then turns the heater off. The temperature falls, so the resistance changes back. The process circuit then senses resistance change, and the output circuit then turns the heater on, and then back to the beginning. So we're maintaining the temperature. And for question number 4, the answer you should have got was 25,000 ohms. If you didn't get them right, please correct them and make sure you understand if you did get them wrong, where you went wrong and how you should have got the answer. Okay, so that's today's lesson in the PowerPoint. You will have a worksheet sent out as well with this lesson for you to complete.